The coupling shaft is one of the three components you'll have to model and document for the coupling assembly. So we're going to investigate the shaft and the straight coupling and the taper coupling. First, we'll do in this lecture, we'll do just the couple shaft. And all the dimensions are provided for you, but as far as the step-by-step, we'll go over how somebody else approached this project. It's not necessarily the best way to do it. In fact, there are a bunch of things that we will talk about being poor procedures and maybe not the way you should do it for the correct design intent. So I'm going to open up the shaft and we'll take a look at it. I'll go to my tools and model player, and as always we'll back it up to the beginning and we'll step through it. Now, one of the things you'll notice is they did all of this work with one command. This feature has actually too many aspects to it. There's ways to simplify it, and if you don't simplify it, then you should build it piece by piece, and we'll show you what we mean by that in a second. You have the taper here. This is the most important aspect of it. So the very first one is a cut called the neck. This is an old style command. It's really just a revolved cut. And you can see that was put in here. Same way up in the front here, another one, another neck command. In here. Neck command really is just a fast way of doing, let's go and let's refit it. Fast way of doing a revolved cut. Some of the choices are made for you because it's going to be a default. But again, we don't have that particular feature turned on, so you're not going to see that in the commands in the dashboard. So we have a lot of small items, and then we have this slot that's put in the top. Another cut. This one is radius actually. It's a radial cut, kind of an odd way to do it. And we have our slot here. This will be the one that we have to do a little bit of construction geometry to get. And in the back here we have a hole, kind of a complicated hole. You can't use a standard hole here. And that hole has a thread on it. And we have a variety of other types of cuts and things that we're putting on here. Most of the items are fairly simple, except for maybe the tapered slot here and the hole in the back. And we have some variety of datum planes that we're putting at the very end. These datum planes are there so that you have an ability to cut sections along the part when you're doing the drawing. And you can see the sections have been provided for you. Section A, B, C. And needed datum planes to pass those sections through. All right, so let's look at the first feature. We'll go to the placement. And you'll see this is quite complicated. And what we want to do here is we want to turn our section. I have a cold, so I'm sorry about my voice here. And we'll click on this. Let's see if we can get it to go. Section orientation, set vertical reference. How about this one? All right. And I'm going to close my model tree over here so we can see a little bit better. Now we'll see we have a lot of diameter dimensions. We do have a lot of stacked up dimensions too, so I'm not saying this is the best way to do it. You're going to have to use these dimensions to create the part, but you also might want to do better dimensioning scheme and not have so much of a tolerance stack up here. The most important thing here is this dimension, is the 2.86. That's one of the most important things. Making sure that this, kind of an odd size to it here, whatever it says in the book, make sure you go by. And what you want to do is match this angle with what's going to be on the taper coupling. So that's going to be important. Now, one of the things that people do when they try to do a complicated section is they try to do it all at once. One of the things you can do to alleviate some of the problems, for instance, let's say you started over here and you sketched, but the only portion you finished was, unfortunately, this is all referenced. I wish there was an all, but there isn't. Just trying to back up through here. And we can see the section here. And I'm going to delete this one. And I'm going to put in from here to here. Now, the reason for doing this is when you do just a portion of the section, you finish it, come completely out of the command, and then you save it. Then you edit the definition of it, and you do it again. I hate to do that. Well, we can try it. Let's see what happens. So here we are. And a lot of stuff is not going to regenerate, obviously. But this is what you have completed in the very beginning. So you say, okay, this portion of it is okay. Edit definition, you go back into the section, and then you add the other material on. You continue your sketching. Now, obviously, you're going to have to delete these. And so, for instance, I can't remember exactly what it looks like, but whatever it is that you're sketching now, no matter how complicated it is, you finish this off. Adjust your dimensioning scheme as per the requirements of the design. Finish it, and save. Now, what that does is allows you to work incrementally rather than all at one time on a section. So let's see if we can go all the way back. There we go. You'll notice I have a different default orientation and a standard orientation. And the default orientation is based on isometric at this time, because I set that up in my options. So under model display, I did change this to isometric. After I'd done that, I wanted to see if I could get another good view. So for instance, the view that I created was the default. The default and the standard orientation are the same in the very beginning, but you can reorient the default. So as an example, if I wanted to, this one is looking this direction. Let's say I wanted one looking in this direction here. And I'm going to go into reorient, and I'm going to click on default orientation and save that. It's going to override the one that's there. So now I can go Control D, goes into isometric, standard, and then the default it'll go over to here. Let's say this is what I prefer to work with. So we did the primary feature, the very first feature, most important one in my case. You can see I got a bunch of neck commands in here, which are again are a little odd, but we'll investigate some of them. So let's go back up here to the very first one, and you can see the neck command comes with some odd menu manager. This is a very old style command, and this is the cut that they put in there. They could have made this as a closed cut also. So let's just to do one of them, let's suppress that, and let's create a cut. So we're going to do a revolved cut, remove material, and we're going to use the datum plane down the middle here. That's going to be our sketching plane. Go into the sketch view. I hate this. It's turning it the wrong way for me, at least. Horizontal reference. Let's try moving it like this. And to be honest, I forgot where it was. So we'll just do one up in here. It doesn't make any difference where we do this cut. So I need some references, and I can select my references, like so. And then I'll need the cut. We'll make a closed section, so I'll use an arc and 3-point. No, let's do an arc and center ends. So center and then end. And then line. And I'll go all the way back because ours will be closed. And you can see that's how we could quickly do our revolved cut. The neck command would have eliminated a couple of those selections for the attributes. I'm not getting it to revolve because I did not do the axis of revolution. So I need this as my axis of revolution. So I selected it. You can see it's going to remove the material. Obviously you don't want to move the material that direction. And that would be the cut. So it's relatively simple. You could change the dimensions here, by the way. You don't have to change them while you're doing the actual sketch. So again, let's back that up. Yeah, it was over here, not over here. Doesn't make any difference. So you've got a lot of regenerated here. See if I can get this to move. You got a lot of different cuts, different styles. But again, they're all pretty much the same as far as your methodology goes. So you use the neck command all along rather than using any revolved cut. We'll go all the way back out to the chamfer, which is at the end here. Nothing particularly important. Now the next one is the slot. And again, this is an old part. Look at our file history. We are looking at 1996 again. So this slot here is going to have some requirements, and one of them is it's going to require that you put a datum plane that's tangent to the position of the slot. Let's turn everything back on there. So let's suppress that. We know we're going to put a slot up here. So the first thing we want to do, we can actually go into the command first, or we can create our datum plane beforehand. And in this particular case, I think we'll go into the extrude tool, remove material, and go over here to the datums and put a datum plane in first. So I'm going to pick the surface here. And it says through, and we don't really want through. We want tangent. And then we want to hold down our control key and gather another one. In this case, you could use this one in parallel or this one in normal. Normal came up automatically. Click OK. So that's my sketching plane. Continue with the sketch. And I would put a construction center line down the middle. And then use my arc command. There's a variety of ways of approaching this. You don't have to do it this particular way. You can also use tangent circles. And finish it off with a line. Now, if it's not tangent, or the constraints don't work well to control it, then you're going to get some extra dimensions. And it looks like we do have some extra dimensions here. We have a dimension here, which is okay. We have another one over here. So something's incorrect, and you need your distance between the two, so you're going to add a dimension. But before you do that, you could put your tangencies in there. So that got rid of one of the dimensions. Now you can continue around, but it's saying it's a valid section now. Let's move the dimensions out. And again, you'll see, depending on where you're going to dimension from, and you probably want the distance between, or in some cases the slot is done from the tangency to the tangency, depending on what type of slot it is. So you could move this around, adjust it, and again, put your proper dimension in there. And you see R1 equals R1, so you only need one of the radiuses. Of course, you want to limit how far down it goes, so it's going to be a blind cut. And you're done. So that one's fairly simple. And I think what we're going to do here is we'll go to our, it says protrusion. Let's see what that one is. Okay, so they added, this is kind of interesting. First of all, I don't think it should be done in this order. If they were doing all the necks, why didn't they do this one also? It's not really a neck, but you'll see what it is. We'll go into the sketch. It's kind of an odd choice. They put in a section, closed section, with an arc in it. So let's cancel that. And let's suppress it. And let's see if we can find an easier way to do it. Let's go and select our round tool. But this time let's pick the surface and then the edge. So surface and edge. So that's not going to work. We're going to have to do a cut instead. Let's try removing this one. So let's pick the surface and the surface. So got the edge as one reference and the surface as the other. So let's do it again. Got your round. Look at our sets here. Our references, surface, and surface and surface. I held down my control key. And you see we can actually adjust this. This gives us what we really want, but we could adjust it. There'll be a place where it fails, I suspect. Oh, no, it doesn't. Very good. All right, so that would work a lot quicker than the method that they had, which is putting in the protrusion. Now they stuck an axis in here. I'm not sure why or where. Put one at the end. That's a little odd. Again, the methodology, don't have to use it exactly. Next one is the slot. Oh, they were probably using it for something to do with the slot for some reason. So we have the slot here. And actually, I'm going to turn the slot. For some reason, I prefer to look at it in this direction. So let's suppress that. And in this case, let's put the datum plane in first rather than during the command. So we're going to select the surface here. If it's through, we want to turn it to tangent. And we will select, for instance, let's select this one and see if we can just use parallel. No, we want normal. So let's remove that. And that will be normal, 90 degrees perpendicular. You can see the angled datum plane. Now this one is inside, it's external to the command. The other one was inside the command, therefore it was hidden. Here it's not going to be hidden. So that'll be our sketching plane. We're going to extrude. We're going to, actually, by doing it so quickly here on the extrude, you can see I forgot to hit my remove material. So we'll see what happens as we complete this one. Now, everything's at a little bit of an angle because we're looking directly into that new datum plane. We're going to start off with some references. And I want to pick this whole surface as a reference. Right mouse button and pick the edge as a reference also. One or the other will work for us. We've got a reference down the middle. And let's put in a sketch point right here. Maybe use that. And then we'll do our construction. Similar to the other one. And we could try something different. We could put in a couple of circles. Equal circles. And then connect them with a line. Tangent. Still active. Like so. Then we got to remove this inner arc on both sides. So delete segment, you can draw through this or you can just click on it. Middle mouse button, you'll see that you get that. Now by putting in this reference from the point, it actually dimensioned to it. If the dimension is not there, then you go from the center to the point here, and that'll be what you need to establish your dimensioning scheme. If you want to go from here to here, you can do that also. So, for instance, you want to go from a point to the arc, and then middle mouse button to place it. Oh, it gave me that one. It didn't give me the one I wanted. Let's try the other thing. I'm going to delete it. No, it wants it. So let's go up and add a dimension. And this time let's pick the arc first and then the point. Middle mouse button still did it. I was hoping to get it from this point out here. So I wonder if, well, I'll try one more time. Got dimension. I think what we're going to have to do is put a point in there. So let's stick another point right here. And let's put a dimension from point to point. And there's my dimension. Okay. Now, if you need a dimension for the radius, you have to add that back in. And it says, which one of these do you want to get rid of? Wants one of these. Oh, they think it's equal. There we go. So we've got too many constraints in here. R1 equals R1. So here's my radius. All right, now I forgot to remove material. So what happens here? It thinks it's adding. So I will remove material and then bring it down. All right, undo that one. And activate the hole. So let's look at the hole. Edit the definition of the hole. And we'll go into the section of it. You can see it's relatively complex. So you have to have a vertical center line or an axis of revolution. Axis of revolution. They changed this. They used to have you put in the center line and then select the axis of revolution. So they streamlined it a little bit. Closed section, obviously, and it's fairly complex. Now, the only thing I would say that's incorrect here is that what I would have done instead I've taken a couple of construction center lines here, like so, and a point, and another construction center line, like so, and maybe one more. Oh, sorry. And let's put this one down here, like so. And oddly enough, you still have to add a point, like so. So now you got your diameter dimension in there, but if you want another dimension, for instance, the included angle, and get rid of the 30, that would be a more appropriate. This should be 60, of course. You'd have to do the same thing on the bottom to get that to be an included angle. So it takes a little bit of construction technique, but it's the appropriate thing to do. Thank you. Now, you have a cosmetic feature here also. And the cosmetic feature, in this case the thread, cosmetic thread, is only going to go from the lip here a certain depth. So you're going to have to select that where it starts and then depth. So the start from here is this lip here, and it's going to have a certain depth. We go over to our no hidden line. We can see it a little bit better. If you turn off your spin center, then it will spin from the position that you're selecting. When you have a long or a large part, you need to do that. So here's your thread. And let's go to the command locator. Let me do it. Back out a little bit. Let's go to my shading. Doesn't allow me to pick in there, maybe because I've got so many things suppressed. But you can't find the command. Then what you need to do is go into, you can look through, oh, I've accidentally found it, come out, cosmetic sketch, cosmetic thread. So you can type in here to find that command. Next, I added a few datum planes and another cosmetic thread. And this one is for the shaft here. And again, if you turn off the shading, you'll see the cosmetic thread is a magenta colored surface, no volume to it. In this case here, they put a datum plane in to start it, and then they have a depth going. It could have gone up to this little lip surface here. Maybe they did. To select it, let's try that. It's because it's a round cut. They wanted to go to the datum plane, or they wanted it to be blind. That's why they did that. I was hoping there would be some sort of an edge there, but there's not. That's the round. So to go up to there, they'd have to have something to click on to show where the thread is going to go to. Put another datum plane in, and then they put another cosmetic thread in. This cosmetic thread is here. And they started from the surface. Threaded surface is green here. The depth, start plane, the datum plane here. Again, let's see. Now they can't use that round, so they put a datum plane through that edge. And they use that as the start. And then to selected, they went all the way out. Probably should have put another datum plane in here through this edge and gone to that datum plane instead. See how far back I can go here. And default orientation. And again, these last ones are there so that you can cut sections. Last datum plane, so you can cut sections through here so that you can have your views and you're creating your sections. It's kind of an odd name. You're not supposed to name anything like this. Must have been a reason you did that. That name, this AA, will actually show up on your drawing, so it's not a good idea to do that. This ends the shaft lecture.